Hello everyone. Today we are solving another lead code question, question number 102. In this question, we are given a binary tree and what we have to do is the level order traversal. This question comes in a simple category. Just you have to know about the graph or the tree traversal mechanisms. Right. So if you have read the graph, I think there are the two different strategy to visit the graph. One is the BFS, another is the DFS. Okay, what is difference between these two? If you are going through the DFS, you first go towards, you take any of the path, you go till the depth of that path, then you come from that path, then go to the depth of the second path. That's how you traversal in the DFS algorithm. In case of the BFS algorithm, what you do, first you select a single node, then you will see what all the nodes which are at the distance one from this particular node, then you select all the nodes which are at the distance two. So this is the way you are actually traveling in the BFS. Now, in this question, why this is relevant, we will understand. But before that, I am just taking the copy of this image, copying on the whiteboard, and let's say I have copied this. Now, let's try to understand what is actually the level order traversal for this. So let me take probably yellow color to make it slightly light. Okay, it means we want to visit this third node first, then all the nodes at a distance one, but from these directions, and then all nodes from this direction. So what should be your output in this case? So first you will visit node 3, after that you will visit node 9, then 20, then you will visit 15, and then you will be 7. So that is your expected output. But instead of giving it as a list of numbers, the question says you have to give the list of lists. So you have to return it like this so that you are very clear at which level which nodes are there. So this you have to return. Now try to understand how you are going to solve. Whenever you have to solve the problem in the level order traversal or the BFS, the thing that you have to use is a queue. So for example, we can consider this is our queue. Okay. Now, for example, first element itself is null. So you will immediately return your answer. You return the empty list. But if you find a root 3, you will first put the 3 in the list. Second element, what element you have to put is null. And why exactly? So for example, we are putting whenever a level ends, we say that level ends with next element as the null. So that is an indicator. You can use any other elements to indicate that a level has been ended. Okay, so I'm using null here, so I put that initially null. Now whenever I have once I remove an element from this queue, so for example I remove the 3 queue, what is the action? If it is a non-null element in case 3, then I will say, does it has a left child? Answer is yes, so insert it here. Does it has a right child? Yes, so I will insert it 20. Cool, then I'm done for this element. Next element, I remove it from the null. As soon as I remove the null, what I have to check? So I will keep a list that is result. In this, I will say, okay, it means I have ended first level. So I will add my result of the first list here. So since it is a single element, it is not very intuitive. Okay. And I will say, let's say temp as well. I will keep track of temp as well for the element which I am visiting. Okay, once you added this element to the result, finally you will again add the null if your queue is not empty. And why I'm considering if queue is not empty, I will come to this particular case. So now you will start visiting 9, you will add 9 here. Does it has a left or right child? No, so you won't insert anything here and this element is removed from here. Now you will remove 20 here. First thing you will add the 20, then you will add its child here 15, and then you will add its right child 7, you add it. Now again you will remove the null. As soon as you remove the null, what you have to do, move these two elements to your result 19 and 20. This is means second list inside a list, so it is representing the second level. And this you again has empty, your queue is not empty, so you will again insert the null. Now you remove the 15. Does it has any child? You won't insert anything. You're putting it into your temp. You putting it into your temp, but you don't have to insert anything. Finally, you again come into the null. This time you will remove it here from 15th, or if you will write 7 here. Now, do I need to insert null here? Okay, let's try. Let's try. Okay, I am adding here null. For example, I add this null here. Now again, I will remove the null. I will keep on adding null, and this will stuck in the infinite loop. So to prevent the infinite loop, whenever I have to add null, I will check if my queue is empty or not. At this point, all element remove, I know queue is empty, so I won't insert anything here. So that's the condition. So I think you understand the question. It is kind of simple category, I will say, though it is marked as the medium in the lead code. And now let's try to implement this in the code. So first you have to do is check the base conditions. For example, root is equal to null. What you will exactly do here, you will return new array list. Now I mentioned we need a queue is equal to new linked list. So in Java, we generally create a queue in this format, queue initialized with linked list. Now we know we have to add two things in the queue, queue.add. First is root element, and then in the queue we'll add the null element. Now only you have to traverse the queue until your queue is empty. Queue dot is empty method. You keep on traversing the queue. Okay, and now you will take an element out of the queue. So tree node. Okay, here in the queue, if it is better if you specify the type of the element you are storing in the queue. Tree node, you are removing the node and queue dot port. So this way you are removing an element from the queue. Now there are the two possibility, either node is equal to null, you will do something, or else node is not equal to null. Now finally we have to return something, return result, but result we have not created. So let's first create the result. What exactly you want in the result? List of integer, and that you can see directly from here. Okay, this is result, and then you say this is an array list. You have created. Now I mentioned we have to create something to store the temporary element as well. List of integer temp is equal to new array list. Okay, now we have the temp, we have the result, and finally we are returning the result. Now we have to populate the results. So for example, if root node is equal to null, at the time what exactly action I have to take? Okay, the first thing I have to do, if my temp dot is empty. If my temp is not empty, I will add it to the result dot add temp, and temp will be again initialized to new array list. Now if queue is empty, queue dot is empty, then we have to break from here. So I mentioned if the queue is empty, then we don't have to again insert the null. So that's why we want to do a break from here. Otherwise, in the queue, I am going to add a null element. Okay. You could have written it other way around as well. For example, you say that if my queue is not empty, then I will add the queue. You don't have to explicitly write the break here, but then above one will take the break. Whenever it reach from here in this condition, it will take the break. Okay, so for node is equal to null, you have written the conditions. Here, first thing in my temp, I have to add the node dot value. If my node dot left is not equal to null, then in my queue, I will add node dot left. Similarly, if my node dot right is not equal to null, Good dot log dot right. So now it should be fine. Let's try to run on the local test cases. Yeah, it passed. Then we can try to submit this problem. Okay. And yeah, it's submitted successfully in terms of the time complexity. Since in the given tree we are visiting every single node at the single number of the times, the overall time complexity of this algorithm is the order of n, where n stands for the number of the nodes. So I hope you like the solution to this particular question, and future I will keep posting other questions as well. Yeah, thank you for watching this.